A lot of people struggled with the systems of equations test. So make sure you pay close attention as we go over these. We'll do systems by substitution, elimination, and then the systems applications. So pay close attention. Make sure you're being very careful with it, writing down all the steps. So when you solve a system by substitution, that implies you're substituting something. So I know in this particular case that x equals what? 5 minus 3y. Because I have x solved for a variable. Or sorry, I have the second equation solved for a variable, which happens to be x. So I'm going to take that 5 plus 3y, and I'm putting into the other equation for x. So I'm going to rewrite this equation as 5 parentheses, 5 minus 3y, and then minus 4y equals 6. So once I substitute that in, I should only have all y's or all x's, and then I can solve for that variable, which we were doing on the front page. We start that by distributing. So 5 times 5 is 25. 5 times negative 3 is negative 15y. What do I do with the negative 4y on the very back? What do I do with this minus 4y? Just drop it down for now. So minus 4y equals 6. The next step is to, after you distribute, is to do what? Distribute and then combine like terms. Negative 15y and negative 4, which is what? Negative 19y. Drop down the equals 6. Drop down the 25. What do I do with the 25 now? I subtract it. So we've got negative 19y equals negative 19. I divide it by what? Just 19? Negative 19. Not quite. Would you rather have negative $19 or $19? So they're different. All right. Negative 19 divided by negative 19 is what?
A positive number?
It is a positive number. Any number divided by itself is what? 1. So this is a positive 1. Now what do I need to do?
More?
Oh yeah. There's a lot more. Once I know one variable, yep. My second equation is the easiest for that, so I'm going to use x. Yep. So x equals 5 minus 3, and because we know y equals 1, we put in 1 for y. So I'm using that equation right there to solve for y, or solve for x, sorry. So then x equals 5, 3 times 1 is just 3, so 5 minus 3, so x equals 2. What's the last step? Check the answer. So I use the first equation, plug everything in. 5 times 2 minus 4 times 1 equals 6. 5 times 2 is 10. 4 times 1 is 4. Does 10 minus 4 equal 6? It sure does. So my answer here is the 0.21. Because x is 2 and y is 1. And those go in alphabetical order if you ever forget the order of the x, y. It's always x then y. Okay. So, when everything is lined up like this, I have my x's, my y's, my equal sign, and my constants, I'm going to use elimination to solve it. With elimination, I need to have opposite coefficients. So the number in front of the x's needs to be the same number with one of them negative. Or the numbers in front of y. But I don't have that in either situation. So in this case, one of them is going to be easier to eliminate. Does anybody know what it is? If it's x or y? X will be easier to eliminate because I can multiply the second equation by what? Negative 3. Because I need to have this as a negative 3, so I'm going to multiply everything in the second equation by negative 3. So when I rewrite this, I'm just going to rewrite the top equation as it is. So 3x minus 4y equals 6. And then the second equation, I'm going to multiply that as negative 3x. Negative 3 times negative 3y is going to be a positive 9y. And then negative 3 times negative 3 is a positive 9. So once I have that, do you always have to do this, by the way? Is it always necessary to multiply your equations by something? No. If you already have opposite coefficients for something, then you don't have to do anything. But in this case, we did not, so we had to multiply the equation by something. Once we're like this, once we have those opposite coefficients, we can just add our equations together, because 3x and negative 3x give us what? What's a negative and a positive of the same thing? 0. If I give you $3 and then I take it away, that's a 0. That's how the x's are getting eliminated. That's why we call it the elimination method. Negative 4 plus 9 is what? 5y equals, what's 6 plus 9? What's 6 plus 10? 16 minus 1. So 9 plus 6 is 15. We do divide it now. By 5. So I have y equals 3. From here on out, the process is the same as the substitution method. Once we have a variable solved, we just plug that into one of the equations to solve for the other. So I'm going to use the second equation, x minus 3 times 3 for our y equals negative 3. So x minus 9 equals negative 3. Add 9 to both sides, so x equals 6. And then, just as in substitution, you check. So if I use the second equation to solve, I'm going to use the first equation to check. So 3 times 6 minus 4 times 3 for my y equals 6. 18 minus 12 equals 6. And I'm good to go. So my point of intersection here is 6, 3. Alright, on the systems application. So it's important to follow the instructions. A lot of you guys did not get credit on this particular one, not because you didn't solve it. Some of you got the answer right on the test, but you didn't set up a system, and that's part of the standard is setting up a system to solve it. So 3 burgers and 2 orders of fries cost $9. How would I write that equation? 3b 2f equals 9. That's one of our equations. 3 burgers plus 2 fries equals $9. So what's the other equation? 2 burgers plus 3 fries equals $8.50. So which one do we want to solve for? Do we have to solve for both in this problem? No, because it's asking just about how much one burger costs. So which variable do we want to eliminate? F or B? Which one do we want to know? We want to know B, so we need to eliminate F. So 2 and 3 can't be multiplied by a whole number to get rid of one of them, so we need to multiply both equations by something. The easiest way to do this, yeah. So I'm going to take my first equation. If I'm getting rid of f, I'm going to multiply the first equation by 3. And I'm going to take this one. I'm going to multiply the second equation by 2. There's one more thing I need to pay attention to. Does anybody know what it is? Negative. 1 needs to be negative, so I'm just going to make the second one negative. And then I'm going to go ahead and distribute and rewrite my system. So 3 times 3b is 9b. 3 times 2f is 6x, f, so plus 6f. And then 3 times 9 is 27. Down here, negative 2 times 2b is negative 4b. Negative 2 times 3f is negative 6f. And then negative 2 times $8.50 is going to be negative $17. Questions on that process? Okay, so now, once you get that part done, it's a pretty simple process. It's just, no, we're almost done. We just need to add these equations. Our f's add out to 0. So what's 9b plus negative 4b? Positive. What's 9 minus 4? Close. 5. 5b. So 5b equals, what's 27 minus 17?
27 minus 17? 12?
10.
So how many divided? I thought you added them.
We do. So 27, so the question there, I thought you added them. 27 minus 17 is the same thing as 27 plus a negative 17. So we actually are adding them. So then 5b equals 10, divide by 5. So b equals 2. So how much does one burger cost? $2. And since that's all it's asking, it's not asking how much the fries are, I don't need to solve for the fries or do anything else. I am done with this problem. And that's it for your final review. Remember that you can have 1-page handwritten notes, both sides, and then the other page can be your substitution and elimination notes.